Okay, so basically this is a uniform ladder, right? It is lying on a smooth vertical wall. What does it mean when they talk about smooth?
Smooth, vertical wall. Smooth.
There is no friction. You understand?
Yeah.
Then, with its other end on a rough, did they say rough horizontal ground or smooth horizontal ground also?
Again, a smooth vertical wall. Yeah, also smooth horizontal wall.
Yes, so there is no friction. So suppose this is our ladder. Do they give us the names of the ladder? As?
They go the ladder?
No, but it's a uniform ladder. So when it is uniform, look here, its center of gravity, the position of the center of gravity is at the center of the what? The position of the center of gravity is at the what?
The center of the ladder.
Of the ladder. So I can say, what is the mass of the ladder?
10 kilograms.
So here we shall have 10 G. Do we believe in this? So I can say let the length of the ladder be 2L. Let.
Oh, it has a ladder of 4. It has a length of 4 meters.
Oh, 4 meters, So this is 4 meters. We shall have 2 meters here and 2 meters here. So what are they asking? Here, of course, they have said there is a string, yes? Pulling the ladder towards the wall, yes? So of course, in the string, there must be
tension.
There must be tension. Are we there? Then they are asking, of course, here, only where the ladder is hinged to the horizontal, there is a normal reaction, which I can call R. Maybe if this is B, if this is A and this is B, this I can call RB. Yes? Then at the wall here, there is also a normal reaction, which I can call RA. Here you should agree that when I get this stuff and I push it here, it will also give me a reaction opposite what I'm doing. If I push you yourself, then you will also provide a force to push me. That is the reaction I'm talking about. You get me? Then, did they give us an angle of inclination?
40 degrees.
40 degrees. Are we there? What else do we need to have? This is the wall. What are they asking?
They think let's find the tension in the string and the normal reaction.
So this guy is in
Equilibrium.
For equilibrium, sum of the upward forces must be equal to sum of the downward forces. It is in equilibrium because it is, of course, it is being supported. To be maintained in a vertical plane, yes? And then it must be in equilibrium. You see, they are saying, yes, a uniform ladder of mass this rests with its upper end against the smooth horizontal wall. A light horizontal string is attached to B and inclined at 40 degrees to the horizontal. The vertical plane containing the ladder and the string is at right angles. For it to remain there, really it must be in equilibrium. If I get this calculator and I place it at my finger, for it to remain here, it must be in equilibrium. Then here it's not in equilibrium. But if it has remained, then it is in equilibrium. Sum of the upward forces must be equal to sum of the downward forces. Don't you feel this is a downward force? Actually, for equilibrium, the sum of the forces in a particular direction must be equal to the sum of the forces in the other direction. Conditions for a body to be in equilibrium. Senior 4 physics, you remember? Very good. It's new, don't you even that. I remember very well. So I'm going to say for equilibrium, yes? Can I say that RB, yes, is equal to 10G, upward, downward. True? So RB is equal to 10 times 9 point, which is 98 newtons. Therefore, the reaction at B is 98 newtons. The reaction at B.
So it's equal to 10 G.
Yeah, because this is upward and this is downward.
Okay.
I'm also about to say, yes, that RA is equal to T. This is a force in this direction, and this is a force in the other direction. For equilibrium, the sum of the forces in a particular direction must be equal to the sum of the forces in the other direction. Are we okay here? Yes? And these guys are very cheap, right? Don't you feel they are? Again, now, because this is RA and this is T, so we don't know what T is. You get me? I am now going to take a moment. This is A, B, permit me call this C. Yes? Now, for me to find the value of T, because T is equal to RA, they are asking us to find the reactions at the wall and at the horizontal ground. Yes? So for me to find the reactions there, I must find the value of T, or the value of R, by taking moments. When a body is in equilibrium, the sum of the clockwise moments is equal to the sum of, when it is of course in equilibrium under the action of a number of what? Forces. Now permit me take moments at point C. And here we simply write that. That means taking moments at point C. I don't want to make this thing bigger by extrapolating here and there. I want it to be as smart as it is. I'm going to take moments at point C. At point C, now, this T will be 0 because it's already in C. A force that passes through C, layer of 0. I think I have friction. Friction force is 0. Then it would have also become 0 because it is in C. If I take moments at B, other B will be 0. If I take moments at A, other A will be 0. Why? The perpendicular distance for RA to move from A to A is 0. And take a moment of the force, the product of force, and the perpendicular distance. So if the distance is 0, no moment. Clear? Now, I'm going to take moments at point C. At point C, this is going to come this way. This is already perpendicular to the distance. Okay, go? Now this, bringing it to C, it will have to go through this distance here. From here up to here. We believe? Now, me and you should agree that this angle and this angle are equal. Because they are corresponding angles. Are we there? Now, if they are equal, this is 2. And now we have an angle. So the distance here becomes 2 cos 40. Do you believe in that?
Yeah, I do.
2 cos 40. Do you believe in that? Or I first explain where it comes from?
From the same thing. From the Sokotoa thing.
Very true. Twice. Now, this is okay.
That is 2 cos
40. For this distance. So we have this, then, attention, this has distance already. For the case of this distance, we have 4 here, and we have 40 here. So for this distance, it's going to become 4, yes, sine 40. Because this is the hypotenuse, and this is the opposite. Opposite and hypotenuse, sine, so high. Are we together? That's where these things come from.
All along.
Yeah. You get me? Then from there, this one is going to be 0. So we have this, and this one. Yes? So for the case of this, for this to move, this will move here, and we have gotten this because it is 4 sine 40. Do you believe in that? Then for the case of this, yes? Now this is going to move through this distance here, from here to here. And this will be 4 cos 40. This is sine, and this is cos. Because this is the hypotenuse, and this is the adjacent. Clear? I'm going to take moments at point C. At point C, this will move this way. Yes? Therefore, crop. Even this will move that way. Therefore, crop. Then this will move that way. Therefore, anti-clockwise.
Other end moving which direction again?
This direction here. Pull it. You see how it moves? You see?
Yeah.
Pull RB. You see how it moves? These things are very cheap. You see how this moves? You see? Yeah. So this is clockwise. This is clockwise. This is anti-clockwise. Should I move on? So for the case of clockwise, I will have other A force times perpendicular distance. Perpendicular distance has become 4 sine 40. You are very okay with that. Then plus this. Now this becomes 10g times 2 cos 40. The guy said you're wise. All together? So this and this is equal to the other one now. Now this is in the other sense. So it's going to become RB times now this distance. So it is 4 cos 40. Are you okay? Because this is the hypotenuse and adjacent. So this is 4 cos 40.
So these topics of mechanics work hand in hand
with being smart.
When they work hand,
they work hand in hand. And people fear them with their heart. So I'm going to now sort about things. I already have RB. RB is 98. So I can make RA the subject of the formula. Can I say I'm going to take a step? Since you are an advanced student, you will see the step. RA is equal to RB, which RB is 98 times 4 cos 40 degrees, yes? Then minus 10g times 2 cos 40 over 4 sin 40. This is very cheap. This one has lost the cosines. I've substituted this. Then to make this substitute with the formula, I divide through by this, and that's what I have. Yes? 98. RB I've substituted because it's 98. Yeah, we got it already. So I can say 98 times 4 cos 40 minus 10 to 9.8 times 2 cos 40. I get the answer and I divide by 4 sin 40. I'm getting 58 point what?
58.3959.
3959, of course, newtons. So I have the reaction at this and the reaction at that. Were they also asking for the tension? Of course, the tension is RA. Tension is RA. I want by the same reasoning to take moments at point B.
Then the normal reaction.
Do you permit me to take moments at point B?
Like we do moments at point B.
Can I first grab this? Let me use this space. Let me use this space. Let me use this space. Eh? Taking moments at point what? At point B. Now, at point B, T is 0, other B is 0. Do you agree? There you go. Then we shall have 10 and this. But then, this is, for this to come to B, it is clockwise. For this to come to B, it is anti. That's sweet.
So this time, for it to come to B,
yes, it has to come this way. Then for this, it must come this way. Are we together? Now, the distance, yes? This will move. Yes? First and foremost, this is now at 40 degrees. Yes? And it must first be at 90, such that it moves this way. The beauty of mathematics. It must first be perpendicular to the distance. Are we together? Then here, this one must also first be at perpendicular to the distance. And how will it be? It must be here. Because now, if this is 40, this is 90, this is 50. Yes? So it must first be straight. So I multiply by 2, just that. You get me? Then here, it must also be this. So I will say, take moments at B. I will have to first resolve the force RA sine 40. Do we believe? RA sine 40 times the distance, which is now 4, for it to be at B. Yes? Is equal to, because by our weighting, this is clockwise and this is anti. So this must be 10G, yes? Sine 50. Got it? Because this is 50. So it must be 10G sine 50. Yes? Then times 2. We get it? Now, what is RA? RA is going to be 20G sine 50 over 4 sine 40. So now, this is 20 times 9.8, yes? And sine 50. We are dividing by 4 sine 40. It must be the same answer. So it is 58.3959. After getting that, the rest will follow in passage.
What do you mean by numeration?